Hello friends, welcome back to the channel. Today I want to tell you an amazing story. You see, nearly 2,000 years ago in the 1st century AD, Greek mathematician Hero of Alexandria devised the world's first engine. And as with most discoveries in science, it was named after him, Hero's engine. Hero's engine was a heat engine, which is an engine that uses the principles of thermodynamics to convert heat energy to kinetic energy, the energy of motion. And even though thermodynamics wouldn't be founded as a field for many years to come, and the Industrial Revolution was at least another 1.5 millennia away, Hero came up with the genius idea for his time. Hero's solution was simple. Take a hollow spherical vessel, traditionally made of copper, and pour some water inside. Seal the opening of the vessel. Now boil the water by providing heat. Now we have the luxury of using a Bunsen burner, but placing it over a wood fire would do the job back then. As the water is heated, steam is produced in the process. Here comes the trick to convert this steam to mechanical work. Two curved nozzles project out from the steam and allow the steam to leave. The steam inside the vessel is at a high pressure and cannot leave through the opening, so it exits through the nozzles. This produces a thrust on the vessel, similar to how a rocket works by ejecting hot gases. The two nozzles are faced the same way around the circle so that their torques or rotational moments add up. This causes the sphere to start rotating faster and faster and faster, and in the process the air drag keeps on increasing until finally the frictional forces and the air drag equal the accelerating torque provided by the gases leaving the nozzles. At this point, the sphere continues at this steady speed until, of course, the water runs out. Something literally very cool happens if you use liquid nitrogen instead of water. Liquid nitrogen boils at minus 196 degrees Celsius. So, at room temperature, it's already boiling and there's no need to heat the vessel. Because liquid nitrogen boils at such a low temperature, room temperature is far above the boiling point, and so the nitrogen expands much more than water does when being boiled. This causes the vessel to spin much more violently than when water is used. In fact, you can find many people doing this experiment in which the system either had too much turbulence to the point that it was dangerous. I mean, you probably don't want a nozzle or bolt flying at you several hundred miles per hour, or it completely broke apart. And this brings us to the practical limitations of Hero's engine and why your car probably doesn't have one inside it. The first problem is, as we just discussed, Hero's engine can become quite unstable and turbulent. Compare that to a modern gas engine, which generates far less vibrations in comparison, and you can start to see the problem. Add to that the fact that you can't reliably control the speed, and you have a recipe for disaster. And most important of all, it was simply inefficient. Very, very inefficient, compared to even a steam engine from a few centuries ago. So why did I call it one of history's greatest inventions in the title, if it's outclassed by a modern engine in basically every metric? Well, it's not because of its reliability, practicality, or efficiency. It's because 2,000 years ago, when paper, the modern number system, and drinking tea were yet to be invented, Hero devised the first heat engine, which wouldn't see any use for almost 2 millennia to come.